Good afternoon, everyone. Solar readiness is Appendix CA for the commercial part of the code. Solar readiness ties in with the green ordinance, so 40% of the roof area would be required to be solar ready, free of obstructions. This is a fairly easy amendment to comply with in terms of it requires you to put circuit breaker space in your distribution gear to accept a solar feed from the roof, and it requires you to run conduit from the electrical room to the roof to facilitate getting the power down. The tricky part about it is, let's say you have a house with a 100 amp panel and you have a photovoltaic array that provides more than 20 amps or more than 20% of your 100 amp overcurrent protection device. The NEC requires you to have busing in your panel. National Electrical Code requires you to have busing in your panel to support both the utility feed and the array feed. So the question is, if you've got a building with a large footprint, you take your 40% of your roof space, are you going to have to increase the size of the busing in your distribution gear to support both the utility feed and your array feed? That's not clear in the amendment. I've been in contact with the CPD. Right now they're saying that the code doesn't require that. So it will be up to the design teams as you move forward with this one. I'm now going to move on to the electrical vehicle charging amendment. Electrical vehicle ready, the definition of that is that you will have pipe and wire run to a parking spot with a receptacle there, run from a panel to feed a future electrical vehicle charging. So the circuit's in place. Electric vehicle capable is that you will have an empty conduit run to that space to support a future electric vehicle charging station, but it's just an empty conduit. You don't have to have a panel. Electrical vehicle supply equipment installed means that you must have a charging station installed. Here are the two tables associated with this. Table 10.1 is for Group R. So if it's a residential project, you're going to have to comply with this table. Table 10.2 is a commercial one. So for example, office or office core shell, you would be under table 10.2. So what I did, we recently finished a residential project right on the edge between Lodo and Rhino. It was 18-story multifamily high-rise, and we're currently starting a high-rise multifamily right down in the Golden Triangle. So I took data from those two projects to inform this slide. 208 volts times 40 amps, so generally speaking, you're going to have a 208 volt feed to your EV chargers. 208 volts times 40 amps is 8,320 watts per space. So if you take 450 spaces times 80,320 watts, you end up with 3 million watts. If you then divide the 3 million watts by 208 times 1.732, which is 360, but that's because you have a three-phase, generally speaking, on this size of the project, you're going to have a three-phase feed to the building. You end up with 10,400 amps. So one way of looking at this is you've got to have provisions in the electrical room large enough to support 10,400 amps just for the electric vehicle chargers. Okay? Now, Denver is not requiring you to put that much amperage in right now. They understand that that's just not reasonable. So Denver is saying that 20% of the spaces right now have to be supported. 5% have to have the EVSE installed, and 15% have to be EV ready. So 20% of the spaces are going to have to be provided right now. So if you take 20% of 450 spaces, that's 90 spaces, times 8,300 watts, you end up with 748,000 watts. Divided by 360 again, that gives you 2,080 amps. Well, they don't make a 2,080 amp switchgear, so I rounded that up to 2,500 amps. And then I multiplied that times $214 an amp. The way I got to $214 was I took all of the switchgear associated with each project and the feeders associated with each project, added those up, and then divided it by the total number of amps for each of those projects, took an average and came up with $214 an amp. So in this case, multi-story high-rise, the total for just the service piece of this amendment is $535,000. Okay? Now, if it's office core shell, it won't be $214 an amp. You might be somewhere in the vicinity of $150 an amp. But that gives you an idea of what the impact is. This is just the switchgear number. On the next slide, I address the branch circuit. Okay? So Denver says you got to have 5% of the spaces have to be EVSE installed. So if you take 5% of the spaces, you get actually 22.5. So you're required to round up. That's 23 spaces. So what I did was I took 12 installed EV chargers at $12,000 each. Now $12,000 is a charge point dual head charger, right? And I used 12 of those because that actually provides charging to 24 stations because they're dual head, right? So that's $144,000 for the 5% EVSE installed. I then took 15% of 450, which is 68. Again, that's a rounded up number, at $800 each. $800 will get you 100 feet of 3/4 inch EMT with 4 number 8 conductors in it and a 50 amp receptacle on the end. So 100 would be an average length of a feed. So you're going to have some parking spots that are closer to the electrical room, some are further away. I used 100 feet as a benchmark. So for $800, I'll get you a EVSE installed branch circuit. The other spaces have to be EV ready. So I took 359 spaces at $280 a space. $280 will get you an empty 3/4 inch conduit from the electrical room 100 feet out. So those are the metrics that I used. So the total, now these stats will work across verticals. Doesn't matter if it's an office building, doesn't matter if it's an apartment building, what it is. For branch wiring, this will work across verticals. Total for the EV branch wiring in this case is $298,920, okay? So then if you take the total for the EV amendment, add the $535,000 for the gear and the $298,000 for the branch, you end up with an uptick of $833,920 for this building. Both of the buildings that I used had 450 parking spots. One of the buildings was around 480,000 square feet, and the other one was 630,000 square feet. So I was working with, I was averaging out between those two buildings to come up with the metrics that I use for this presentation. I've got one more slide that I'm going to be addressing that breaks it down for you in an easier way to look at. So accessible parking spots, you've got to have an EV charging station. Parking garage lighting control is also addressed in the amendments. If it's less than 0.08 watts per square foot, you're not required to use lighting control on your parking garage. The last two parking garages we designed, our lighting power density was 0.06 watts a square foot, so it's certainly achievable where you can get in under 0.08 watts a square foot. If you are 8.8 watts a square foot or better, it says if you're within 20 feet of the perimeter, then you've got to dim them. The problem is, my problem with that is, if you're at 0.08 watts a square foot and you're dimming it, your return on investment for the dimming system is going to be a long time because at 0.08 watts a square foot, it's going to be hard to pay that back. So I would advise you to put your fixtures 20 feet and 1 inch away from the exterior, and you'll be good. All right, so usable data. We were talking about the EV charging station. So what I did was I took the $833,920 and divided by 450 spots. I came up with $1,800 a spot, right? So that's what it costs in my example to comply with the EV charging stations. The cost per square foot, I took an average of the square foot between the 630 and the 480, came up with 545,000 square feet. Divided that into the 833,000, and it came up with $1.53 square foot. So for a high-rise multifamily, I think $1.53 a square foot is probably a pretty decent metric. And I also think the $1,800 a square foot. I did one more check. I had a third example, high-rise multifamily. It was 247 spots, and it came out at $1,700 a spot, $1,700 and change, so about 100 less. So my methodology actually translated over a project that was about half that size. And so I approach this from an electrical contractor point of view, and I hope you found that useful. Thank you.